Welcome to Pomodoro Joe for Tuesday, June 13th, 2023. Today we're doing LeetCode problem 2352, equal row and column pairs. This is a medium problem. Given a zero-indexed n by n integer matrix grid, return the number of pairs r sub I, c sub j, such that row r sub I and column c sub j are equal. A row and column pair is considered equal if they contain the same elements in the same order, i.e. an equal array. All right, and then we have some examples. Okay, and it looks like, so we'll go through, we'll find all the different rows and all the different columns. Then we can just pair them up and find the different combinations. So we can use a set for this, and we can use a set intersection to find an intersection of the rows and the columns. And then we'll be able to figure out how many pairs we can make with those intersected rows and columns. Except I'm just noticing here, we have the same row multiple times. So a set won't work because a set only stores unique values. Oh man. Okay, so we will have a dictionary and we will store a count of the rows. Okay, we can do that. We have some constraints. We have n, so it's an n by n matrix. It's between 1 and 200. Okay. All right, well, we'll put 25 minutes on the Pomodoro timer and we will get started. Okay, so first we'll have a result. We'll set it to 0 to start and we'll return the result at the end. Let's see, now for this we will need to know our columns and our rows. As I mentioned earlier, I had planned to use a set, but given that we could have duplicates, I can't use a set, so I'll use a dictionary. And for this, I'll use a default dictionary. Now it'll be a little bit tricky because you can't use an array as a key into the dictionary. We'll have to convert these to something that we can use, and that will be a tuple. Okay, so we'll have rows. That will be a default dictionary, and it will be default dictionary with a value of integer. So for this, let me put a little note here. The key will be the row, and the value will be the count. Okay, and we'll want the same for our columns. So cols, and for this one, the key will be the column, and the value will be the count. Okay, so we'll have to go through, extract our rows and our columns. Then for every row column pair that match, we can basically increment our result or increase our result by 1. Okay, so first let's pull out our rows and our columns. So for this, we'll need to know how many there are. We'll have to have this n, because it's an n by n matrix. So our n will be the length of our grid. All right, so for this, I will start going through every row and column. So I'll go through every row, and then for every row, okay, this is going to be a little bit tricky. I'm actually going to be using, I'll be using the index for both the row and the column, which is a little bit tricky, but bear with me here. So for every I in range of n, so this will basically give me an index for every row or column. Because it's an n by n matrix, I can use this I for either rows or columns. So for this outside loop, I'll use it for a row. So we can get the row at this index. So that's just going to be a grid at index I. So that will be our row. Now I want to add this row to our rows dictionary. So our rows for, now I can't just put the row here. So I can say row, rows at index row. This won't work because the row itself is not hashable, because lists are not hashable. But if I convert this to a tuple, it is hashable. And we can just add 1 to this. Because this is a default dictionary, it will start at 0, and we'll just add 1 for this row. All right, now out here, so this is where the trickiness comes in. I need to create a column. Now, the column will be a new list. Now we have a row, we're using this I to give our row. Well, now we're going to use this I to be our column, and we'll have to go through every row to pull out the element at that row and column and put it into our blank column here. So for every j in range n, so we'll get the column. Oh, let's see, I've already used this call. I'll call it value. There we go. So we'll grab the value at the grid. Now, I'm flipping the meaning of this I. For here, this I was our row. Now I'm going to use this I as our column, and I'm going to use the j as our row, because we have to go through the same column, but in every single row. So we want the thing that advances to be our row, and we want to keep our column static. So that's our I here. So our value will be at grid ji. And now we can put that value in our column. So our column will append this value. Now, after we go through the loop, we build up this column. Now we can add this column to our calls dictionary. And we have to do the same. We have to wrap it in a tuple. And we will add 1 to that. Okay, so now we've built up our 2 dictionaries, a dictionary of rows and a dictionary of columns. Now each key into our dictionary is unique, and the value will be the count of that key. So that's basically how many rows do we have of this value. So this 2422, we will have 1 key, 2422, and its value will be 2 because there were 2 rows. All right, now we have to go through for every column and row key combination that match how many rows and columns are there, and then we can add those to our result. So for this, we can just say for every key in our rows, if that key is in the columns, that means that there is a row and a column that match. And now to get the combinations of those rows and columns with the same values, we just multiply their 2 values together. So our result will be increased by the rows at this key times the columns at this key. So if we only had 1 row but 5 columns, then we have 1, and then you can do 1, 2, 3, 4, 5. So that gives us 5 different combinations. If we had 2 rows of the same value and 5 columns, then you could do 1, 1, 2, 3, 4, 5, and then 2, 1, 2, 3, 4, 5. So that gives us 2 times 5. All right, so that's going to be our rows times our columns at that key, and we've got our result. Okay, so I think this is it. Let's give it a shot. Okay, seems to work. Let's see how we do. And we pass. And we do okay. We beat 45% for runtime and 74% for memory. So that's not too bad. Now I'm going to jump back and do one thing here to make this a little bit faster. Well, 2 things. I'm going to get rid of these comments. And then right in here, we have this loop we're going through for every I and j, building up these rows and columns. One thing we can do is instead of going through, how do I explain this? There's a better way to do this, or a more Pythonic way of doing this. We're still going to be building up our rows and columns, but we'll do it in a slightly different way. So the rows, so for this, we can just grab the row in our grid. So this is going to grab every row in the grid, and we don't need to use our index here anymore. And we'll just add that row to our rows here. Now the columns, let's see. For this, we will actually have to convert our columns into rows. And one way to do that is to actually rotate our entire matrix. So if you took this entire matrix, so all these rows, we want to convert our columns into these rows. So these columns, we want to convert to rows. We can do that if we rotate our matrix. Now I want to keep the same ordering. I want this 2, 5, 2, 2. I don't want to rotate it clockwise. I want to rotate it counterclockwise. So I have 2, 5, 2, 2 here. Now this is sort of the Pythonic way of doing it. I'll have this, I'll call it rotated grid. So for this, we need to create lists out of, we'll do a zip on the unpacked grid. And I'll walk through this a little bit to explain it. And then we go through our rotated grid. So for a column in our rotated grid, Then we'll add the column as a tuple, and everything else stays the same. So this is just a fast way to convert our columns into rows. And so how does this work? So we have our grid. That part we understand. That's just a bunch of rows and columns. Now this star before the grid is called the unpack operator, I guess. So the star means that we're unpacking the grid. And what unpacking means is you can imagine it's just taking every single element in the grid or every single row in the grid and passing it to zip as a separate argument. So now we can just lay out all the rows as if they were arguments into zip. And now what zip does is zip will go through every single one of its arguments, grab the first element, pack it together as a tuple, and return that. Then it will go through every single element or every single argument in its input, grab the second element, pack it together, return that. Then it goes to the third, fourth, fifth. So zip will basically go through every argument, grabbing each element in turn, packing them together, and returning them. So this is taking essentially row 1, element 1, row 2, element 1, row 3, element 1. That's our column. So it's going to grab our first set of column values, return those. Then it grabs the second column values, return those. Third column values. Now we're packing them up into lists, so we can still have a grid of lists when we return. Okay, so it's going to take every column, turn it into a row, and it's going to do it in the proper order. So we're going to grab 3, 1, 2, 2, and it's going to turn that into a row, 3, 1, 2, 2. Okay, so hopefully that makes sense. If it doesn't make sense, just do maybe I'll leave a link. Yeah, I'll leave a link in the description. You can check it out. All right, let's see if this still works. Still works. Let's see if we do any better. And we do significantly better. So now we're beating 76% for runtime and 26% for memory. So that's up from a 46% runtime, 45% runtime, and 74% memory. All right. So that is it for me on this one, I think. Yeah, this is pretty short and sweet. I kind of like this one. All right, check this one out. Again, this is LeetCode 2352, and it's a good problem. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.